Well, now it's time to wrap up our discussion of fixed income valuation. We've looked at a lot of different yields and a lot of different calculations. The last thing we want to look at here is yield spreads. So if we take the yield to maturity on a bond and subtract the yield to maturity on a risk-free bond of the same maturity matched up, we're going to call that the yield spread. So that risk-free rate typically would be a government rate, government bonds in a number of companies, or excuse me, number of countries. And that risk-free rate is driven by macroeconomic factors, right, in the overall economy, our risk-free rate or government bond rate. The spreads are going to be driven, we say, by microeconomic factors because those are for specific bonds. We'll look at corporate bonds compared to government bonds and look at that spread. And we also consider some spreads based on other factors. So the first term we need to learn here is the G spread, and the G stands for government. So it's the spread to the benchmark government bond yield for the same maturity. So if I take a corporate bond, a 10-year corporate bond, say A-rated, it's got an 8% yield. I look at the government yield, it's 6%. For that same maturity, we say, well, the spread to governments is 2%. So it's a spread in yields to maturity. Now the yields for the governments can be on-the-run bonds, and that means bonds that have been very recently issued, they're actively traded, very liquid, or we can use interpolated yields. Remember when we constructed our government bond yield curve, we did the 1, 3, 5, 7, and 10, and then we do straight lines between the points. Those are going to be our interpolated yields for maturities between those dates we calculated them for. Now in the Eurozone, they don't use government bond rates, they use the swap rate, the fixed rate in a fixed for floating swap, which we'll discuss in our derivative section. So we use, just for now, they don't use government bond yield to maturity, they use the fixed rate from a swap. For example, a 5-year corporate EuroPay corporate bond might be quoted as mid-swap plus 80 basis points. Well, mid-swap is between the bid and the ask, the buying and selling side of a swap. So mid-swap, and then 80 basis points is the spread. That's the additional yield on the corporate bond compared to the fixed rate in a swap. And so this spread represents the credit risk difference between interbank lending, LIBOR rates that are driving the swap rates, and the bond. So we can think of this as a credit spread. But remember, I spreads, interpolated spreads, use the fixed rate from interest rate swaps. And then we've got the Z spread, or static spreads. So we can think of it as the zero spread or the static spread. And it's static because when we calculate them, we're assuming that the bonds aren't affected by changes in rates. That's the static part to it. So as an example of a Z spread, now we're not going to do the spreads based on yield to maturity. We're going to do the spreads based on these zeros or spot rates. So we've got Treasury spot rates now, not yields to maturity. We've got our Treasury spot rate curve, and we've got the 1 year at 4%, the 2-year spot rate is 8.2, and the 3-year is 12.4. Remember, those are all annualized rates, even for the 2 and 3-year periods. And we've got a bond, an annual pay bond that's priced at $89,464. So there's our present value. Here's our coupon payments and our coupon plus the par value at maturity. And then we plugged in our spot rate curve. So we are now going to solve for this amount right here. It's the same amount. It's that single amount increase in interest that we would need to add to each spot rate to price correctly this corporate bond. So that's the market price for the corporate bond. Clearly, if we used the spot rates for Treasury bonds, which have less risk, we'd overprice it. So we've got to add something. We've got to add Z to each of these. Now, calculating Z is not something that you need to be able to do for the exam, and it's done by trial and error anyway. There's not a closed solution formula to this. You just try different Z's, and by iteration, until you get the price equal to 89.464% of par, which is what the market says it's worth. So what we're really talking about is a spread to the yield curve now. When we talked about the G spread and the I spread, those were spreads between yield to maturity on the G spread and to the fixed rate for some time, whatever time period, whatever the maturity is. Here, we're talking about taking that spot rate curve and how much would we have to raise that in a parallel fashion, right? Same amount added at each maturity. And that's our Z spread. So it's a spread to the curve, not a spread to a point on the yield curve. And option-adjusted spreads. Well, we talked about adjusting for the options embedded in bonds earlier. We'll look at it in terms of yield now instead of terms of price. The option-adjusted spread is the Z spread minus the option value. So when we think of option value with a bond with an embedded option, it's the cost to the issuer in basis points per year. Now remember, for a callable bond, the yield has to be higher to compensate bondholders who are short the call option. The call option is owned by the issuer. So for example, consider a 10-year callable bond with a Z spread of 180 basis points and a call option that increases the market yield 60 basis points compared to an otherwise identical bond without a call feature. So now we can just subtract off the increase in yield because there's a call feature from the Z spread that we calculated based on the price of the callable bond. So we got a Z spread that was bigger than for an option-free bond. We subtract off the cost of the call option to the issuer, 60 basis points, and we get an option-adjusted spread of 120 basis points. And again, this allows us to compare bonds with options features to bonds without option features to see which one is trading lower and offering a higher yield after we adjust for differences in optionability of the bond.